and I will collect all the problems that I will solve in all the sections, and I will upload it to the Blackboard or give it to you on the WhatsApp. It's up to you. Okay. So let's see something else. A person travels by a car from one city to another. He drives 30 minutes at 80 kilometers per hour and 12 minutes at 105 kilometers per hour and 45 minutes at 40 kilometers per hour. So here we have 3 periods. And he spends 15 minutes eating lunch. So that's the 4th one. Okay. What is the average speed for his trip? What is the average speed? Total what over total what? You remember? Distance. So here I need to calculate total distance over total time. So how to calculate the total distance? Here I have 4 parts. He said he drives 30 minutes at a speed whatever. So how to calculate the distance here?
E equal VT.
V times T. So I will calculate the distance for the first part, the distance for the second part, the distance for the third part, and divide it over the total time, T1 plus T2 plus T3, plus the time he used to eat lunch and buy gas. So let's say what's D1? The speed times time. But take care that the speed is kilometer per hour, while the time is 30 minutes. So 80 times what?
Half.
30 minutes is half an hour. 30 minutes is half an hour. So 30 over 60 plus the second stage, 105 kilometer per hour times 12 minutes.
1 over 5.
So 1 over 5, which is 12 over 60. Okay, so each time I will divide over 60. Plus the third one is 40 kilometer per hour times 45 minutes.
3 over 4.
3 quarters. 3 over 4. Okay. Divided by the times, all the times. The first time is 30 minutes. I have to divide. If all of them are in minutes, I will divide all of them over 60. So 30 minutes plus 12 minutes plus 45 minutes plus the lunch will take 15 minutes. So all of that, you need to divide them over 60. Okay. And by the way, we divided in the numerator over 60. We divided over 60. And in the denominator here, we also divide over 60. So it doesn't matter if we use minutes in the numerator and denominator, because either way you divide over 60 in the numerator and denominator, so they cancel each other. Okay, so we can make it easier if we want. Instead of changing in the numerator and denominator, we can keep it. So that's 30 minutes, and this one is 12 minutes, and this one is 45 minutes. And I will not divide over 60 in the denominator, so it will give you the right answer also. Okay, so anybody calculate it, please? Do you have calculators? Could you please do it?
That's 53.5.
53?
53, yeah.
Okay, it's 53.5 kilometer per hour. Okay, guys, let's see something else. I think this one I gave it to you before in one of the assignments.
Yes, you did.
Okay. Do you need it, or should we move to something else? I solved it before. You will find it on the Blackboard, so you don't need to go again to this one. So this is, it looks like a projectile problem. So as shown in the figure below, a projectile is fired horizontally. And as I said before, the projectile has many cases. You might fire it downward or upward or horizontally or at an angle, up or down, or all of these cases, okay? But we are going to study only one case. Inshallah, in the Physics 101, you will study all the other cases. But this year, we study only one case when you fire the projectile horizontally at a speed 30 meters per second from the top of a cliff 80 meter height. So this is H. With what speed will it strike the level ground? So we need to know what's the speed of the projectile as it strikes the ground. And he means here before it strikes the ground. What he means is directly before. Because when it strikes the ground, it might bounce a little bit, then it will stop at the end. So what speed or at what speed it will strike the ground at the base of the cliff? And here he didn't say horizontal speed and he didn't say vertical speed. He just said speed. So he means total speed. And the total speed of the projectile, guys, equals what? Equals the horizontal speed square plus the vertical speed square. So the projectile has two speeds. It has a horizontal one and vertical one. The horizontal speed, or we call it x speed, Vx, equals 30, exactly like the initial speed. Okay, so this one has no problem. So this is 30 square. And there is a vertical one. Okay, there is a vertical one, Vy. How to get the vertical speed?
We can use that Vf squared is equal to Vi squared plus 2Hg.
Yeah, we will get it by using H. So there is an equation says V square or Vy square equals Vy initial square, which is 0 because we fired horizontally, plus 2 times G times H. So Vy is the root of 2GH. Okay, I think you remember that. So it's 2 times 9.8 times height, which is 80 meters. And by the way, we don't need, it's better to keep it V square. Why? Why do we need to keep
because
it V
we
square?
don't need the vertical
Yeah.
speed. We need the total speed.
Yes, but so we need it squared because we will use Pythagoras theorem.
Yes.
Okay, so we don't need to take the root and then we will square it again. So the result here is what?
1568.
68. So I will plug it here. 1568. So the result is what?
49.
First one is 900.
49.6.
49.6 meter per second. So that's one of the good questions actually. Okay, and I expect that you might get something similar in the final exam. Okay, asking about the total speed. So the total speed, you need to get the horizontal and the vertical, and then take the square root of the first one square plus the second one square.
Doctor, I have a question.
Yep.
How can I know that he means to get the total speed, not the y component?
If he says only speed of the projectile, so that's total speed. When I say speed in general, so this is total speed. In any case, speed means total speed. Okay.
And velocity?
If you want to specify it, you need to say horizontal speed or vertical speed. In this case, you mean one of them. Velocity also the same, but the velocity needs a direction. If I say velocity only, so I mean the total velocity. But when I say total velocity, I need to get the total magnitude, okay, and I need a direction. So in this case, if he asks, what is the velocity of this projectile? So you will get the magnitude like what we did, but also you need to get a direction. So how to get the direction, guys? How to get the direction of the velocity?
We write that right triangle.
Angle.
So there is an angle here. Okay. So we can complete a triangle like this. Okay. The angle theta. I have here Vx and Vy and V. So tan theta equals what?
Vy over Vx.
That's it, Vy over Vx. Okay. So Vy is the root of 1568 divided by Vx, which is 30. So if you have a calculator, you can calculate tan theta and then shift tan, it gives you theta. Could you please do it if you want? 60?
Yes, 60.1.
60.1 degree. Okay, so this is the velocity. I have a magnitude and I have a direction. Okay, understand it? Okay. Okay, the radius of the Earth is about 6,370 kilometers, while that of Mars is 3,440 kilometers. If an object weighs 200 Newton on the Earth, so the weight on the Earth is 200 Newton, which is the mass of the object times the gravity of the Earth, which is 9.8. What would be its weight, or what would it weigh on Mars if the mass of Mars is 0.11? That's of the Earth. So he says here, the mass of Mars equals 0.11 of the Earth, the mass of the Earth. So what should we do? I need to find the weight on Mars.
So the change will be in G. The
Yes.
mass will be the same.
Yeah, so the change here in gravity. Okay, so the gravity of Mars equals what? Big G, let's remember the equation, times the mass of Mars divided by what?
Radius.
The radius of what?
Of Mars.
Mars
Square.
square. Okay. How to behave in this equation?
We can change the mass of Mars as 0.11 mass of Earth.
So I will write it down, 0.11 times mass of Earth. What else? You need to do also the same with the radius.
Divide the radius of our Mars over the radius of Earth.
Can you do that? The radius of Mars over radius of Earth gives you what?
The percentage of...
Yes, yeah, I know. Like, could you please do it?
1.85.
1.85.
85. Yeah, one.
No. I need Mars over Earth.
0.54.
Yeah, 0.54. So we can say the radius of Mars equals 0.54 the radius of Earth. So we do also an equation. Okay, guys? Then let's try to substitute it here, but take care that it's squared. So I will remove radius of Mars square and write it down, 0.54 times radius of Earth square. And let's try to simplify it. Take the 0.11 outside, and 0.54 square, it will be what? 0.54 square. It will be 0.2916 times G times mass of the Earth divided by the radius of the Earth. Let me write it. Okay, it doesn't matter. Radius of the Earth square. What's this?
This is the mass on the Earth. The weight in the Earth.
Nope. What
The
this?
gravity of Earth.
This is the gravity of Earth. Okay, so this is 9.8. This part is the gravity of the Earth. Okay. So this is the gravity of the Earth, which is 9.8. So you can say the gravity on Mars. Can you calculate it? 0.11.
It will be 3.696.
96 meter per second square. So that's what we need. We need the gravity on Mars. So the weight on the Earth was 200 Newton, which is the mass times the gravity of the Earth, which is 9.8. We need the weight on Mars. The weight on Mars equals also the mass times 3.696. So you can get the mass from the first equation, plug it in the second equation. So the mass is what? 200 divided by 9.8 times 3.696.
It will be 8.
8?
Yeah,
Yeah, 75.4.
75.44.
Okay. So this is the result. So at the beginning, we need to get a relation between the gravity of Mars and the gravity of Earth. And then we can substitute it back in this equation. Okay. A person lifts 1,000 kilogram car using the automobile jack that has a mechanical advantage 70. How much force does the person apply on the jack? So if you try to lift a car, the weight of the car or the mass of the car is 10,000. So the weight of the car equals 1,000 times 9.8. This is the weight, okay, which is a force. I need the weight of the person. The weight of the car, this is the output. Why? Because you lift it with a jack. What is the function of the jack? You give it a force. This is a jack, for example. You give it a force. You try to pull it down with a force. So you lift the car up. So you affect on the car by a force, which is the same like the weight of the car. So the mechanical advantage here, mechanical advantage equals the output, which is the weight of the car, over the input, which is your force. Your force. So I need to find your force. So your force equals what? The weight of the car.
Divided.
Take care, you need to change it into Newton. Don't leave it over the 70. What's the result?
140.
140. So the force will be 140 Newton. Let's try to see something in the, yeah. Density. The density of helium gas at 0 degrees Celsius is whatever. The temperature is then raised to 100 degrees Celsius, but the pressure is kept constant. Assuming that helium is an ideal gas, what is the new density of the gas? So he gives us, what's the density? Density is what? Mass over volume. Over volume. Mass over volume. Okay. So the mass here does not change. I have some helium in a tank or in a balloon or whatever. So the mass does not change. So the change here is in the volume because he changes the temperature. The density of the helium, he gives it to us at 0 degrees Celsius, and he wants the same density or the other density when he changes into 100 degrees Celsius. So let's find the relation between volume and temperature. What is it?
V over T equal V over T2.
So V1 over T1 equals V2 over
Jacques
T2.
Lawyer.
What is it?
Charles.
Charles. Yeah, that's a Charles law. That's
Charles,
right.
yeah.
Excellent. But we need to take care in Charles law. We cannot plug the temperature in Celsius. We need to change it into Kelvin. Okay. So the first temperature is not 0. It's 0 plus 273. And the second temperature is not 100. It's 100 plus 273. So this is the first point we need to take care of. For the volume, we said there is a relation between rho, m, and v. Rho, this is not pressure. This is rho. If you remember, the rho is the density.
Yes.
So the volume equals what from this equation?
M
Equals
over
mass over
density.
density. So I will remove V1 and I will write it M over rho 1. And V2 is also the same mass because the mass does not change. If you have some mass in a balloon, the mass does not change because it's the same amount of gas. But the problem is when you increase the temperature, the volume might increase. Okay, while the amount of gas is the same. Okay, so the number of atoms are the same. So M over rho 2. We can remove M with M. Very easy because it's the same amount of gas. So I will find what equals what. Let me write it here.
Rho 1.
273 times rho 1 equals 373 times rho 2. Rho 1 is given 0.179. 0.179. So I can get rho 2. Rho 2 equals what?
It will be the number divided by rho 2 by 373.
Yeah, what is it at the end?
Doctor, 273, we should multiply it by rho 2.
Again?
0.131.
0.131. Okay, that's right. What's the question?
Here, Doctor, 273, we should multiply it by rho 2.
Why? I have V1 over T1 equals V2 over T2. V1 is the mass over rho 1. So this rho 1 will go to the denominator. So it becomes here rho 1. And V2 is mass over rho 2. So rho 2 will go to the denominator also. It will be times rho 2. Mass goes with mass. So it will be 1 and 1 here. So T1 times rho 1 and here T2 times rho 2. So we did it right actually. Okay. Which of the following is a substance? That's easy one. Pure
Neon.
substance. Pure substance.
Neon.
Neon. Wood is not a pure substance. Okay. Wood is like a heterogeneous mixture. Okay. Smoke is considered usually as a colloid. Milk, it's usually is a colloid. Tea, what do you think tea is?
It's colloid.
Colloid.
Is it colloid or a solution?
In the
Say-
book,
think
it says that it's colloid.
The book.
It depends on the tea. If it is a British tea, it will be a solution. If it is like Egyptian tea, it will be a colloid. Okay. Okay. Which diagram below shows a mixture? Which one is a mixture?
It's
Of course, not this one.
no, why Z I said. Sorry.
Okay.
It's
The one here, it looks like a pure substance because it has molecules, like the same atom molecule, so it's a pure substance. The first one,
it's a compound.
it's a molecule also or a compound. Okay, so it's a pure substance also because it's a compound. This one is a compound. I don't care what is it, but they are chemically bonded. They have a chemical bond here. So that's not a mixture. Okay, the third one, I have, this is a compound and this is another compound, and they are mixed. There is no chemical bond in between. So it's considered as a mixture. Okay. We need something about the buoyancy. Let's see something about buoyancy. I cannot see anything. Anyway. So let's move to some chemistry. An atom has a mass number 55. Its number of neutrons is the sum of its atomic number and 5. I think I give
Yes, you
one
did.
in the quiz like this one.
Yes.
Yeah,
Yes.
Okay, so we don't need. Do we need to solve it? What do you think?
Oh no.
I
3.
don't think so.
clear.
The masses of a naturally occurring isotope of gallium is 68.9 whatever AMU for gallium 69 and 70.9 for gallium 71. What is the percent abundance of gallium 71? So here we have two isotopes. We have gallium 69 and gallium 71. We need to find the percentage of gallium 71. So gallium 69 has a mass 68.
0.9257.
68.9257. And by the way, this is the real mass. This is not the mass number. This is the real mass of the gallium 69. And
Okay.
gallium 71 has a mass 70.9249 atomic mass unit. What is the percentage of the abundance of gallium 71? So I will assume this is X and the other one is 100 minus X. So I will multiply each one times its abundance. So gallium 69, so its mass is 68.9257 times 100 minus X plus the mass of the other one, 70.9249 times X. So each one times its abundance divided by 100, or if you don't like to divide over 100, it's up to you, but it will give you X as a fraction. Okay, so X will be as a fraction, so you will need to multiply it times 100 after you finish. Equals to what? Equals to the average mass. How to get the average mass? What's the average mass of gallium? Look at the periodic table. So please look at the periodic table, find the gallium. Gallium is number 31. So it's 69.72. Okay. So I will give you 1 minute. Try to do it. 68.9257 times 100 minus 68.9257 times X plus 70.49 times X equals 69.72. You'll take this number, take it to the other side, add those numbers together, but take care this is negative here and this is plus here. So what's X? Everybody tries, please. So you will take this number to the other side, it will be negative. You will subtract it from the 69.7. Should I do it myself or what?
Just do it in the picture.
Huh? Let me do it. 69.72 divided or minus 68.9257.7943 and 70.9249 minus 68.9257, that's 1.9992. So that's 0.7943 divided by 1.9992 gives you 0.397. So this is the fraction. You will need to multiply it times 100 because I did not divide over 100 at the beginning. So if you multiply it times 100, gives you 39.7%, which is very close to 40%. Okay. Which of the following is a which of the following chemical formulas is wrong? Which one is wrong?
KO2.
K and O. K is +1 and O is -2. So what's X and Y?
X is 2 and Y is 1.
2 and 1. So it must be K2O, not KO2. Let's see the other one. Mg and O, magnesium and oxygen. Mg is +2, oxygen is -2. So what's X and Y? 1 and 1. So this one is right. Na and PO4. PO4 is a polyatomic ion. Okay.
Negative
So sodium is +1, PO4 is -3.
Yes.
So it should be 3 and 1. So it's right. CaCl2. Ca is +2, Cl is -1. So I have here 1 and 2. So it's CaCl2. It's right. NH4 2s. NH4, that's +1. It's a polyatomic ion. And the sulfur, it's 2, -2. So X and Y will be 2 and 1. So it should be NH4 total 2 and only 1 S. So this is right. So the only KO2 is the wrong one. Okay. Which of the following compounds has the correct chemical formula or the correct chemical name? BAS is what? Ba is barium. Barium is a metal. Sulfur is a non-metal. So it's an ionic compound.
Yes.
So it should be barium sulfide, not barium monosulfide. So that's wrong one. COCl2, cobalt and chlorine.
Ionic.
Cobalt and chlorine, that's ionic compound. Okay. So he says here cobalt dichlorine, so that's wrong one. And by the way, the cobalt, it has multiple oxidation numbers. Okay. So you need to tell which cobalt is this one. Okay. So that's cobalt 2, by the way. Cl2O7. So Cl2O7.
Hepta.
Hepta, not penta.
Yes.
Okay, so that's also wrong because it should be heptoxide. P2O5.
He didn't
He's
say.
a covalent and he didn't write penta.
Didn't say diphos.
Yeah, the phosphorus and oxygen, they are non-metals. So he should say diphosphorus pentoxide. but he said here phosphorus oxide, so that's wrong also. The first one is S4N4. S4N4. That's also covalent. So S4 is tetra sulfur and N4 is tetra nitride. So this one is the only right one. So this is the correct one.
Doctor,
Yes?
the last option, it should be barium monosulfur.
No, it should be barium sulfide.
Okay.
It's an ionic compound.
Because it is metal and non-metal.
Yes. Okay, and the barium has low electronegativity, sulfur has high electronegativity, so that's typically an ionic compound. Okay, but in general, as we said, if we have a metal with non-metal, that's ionic compound, except in some cases like beryllium. In case of beryllium with chlorine, beryllium with bromine, beryllium with sulfur, with all of these elements, it makes covalent compound. So the beryllium is like a special case. It makes sometimes ionic bond, sometimes it's covalent bond. I think it makes covalent bond, or I think it makes ionic bond with fluorine and maybe with oxygen. I think fluorine and oxygen, but the other elements, it makes covalent. I think so. Which of the following statements is false? I think you get this one in the quiz yesterday.
Yes.
Okay, so I think you might know it. And I solved it to you in the lecture notes. This one here, the map below shows the location of an earthquake epicenter in New York State. Seismic stations K, H, and P received the data used to locate the earthquake. So here I have 3 circles. They intersect in one point. So this one point is the epicenter. Okay. So he asks about what? The seismogram recorded at station P. At station P would show what? The shortest lag time, the greatest lag time, arrival of S wave before arrival of P wave, of course not. Arrival of P wave only, I don't think so. Arrival of S wave only, of course not, because like the S wave cannot arrive alone. The P wave can arrive alone, but in very long distances. Like you need to be, for example, in America, and we will sense your signal in Australia, for example, or in maybe the Atlantic Ocean, the south of the Atlantic Ocean, something like that. In this case, we might receive P only and no S. As we said, there are some shadow zones. But here we are talking about New York. So all of these stations are in the same area. So station P, it has the smallest circle. Smallest circle. So what does it mean?
The smallest lag time.
Shortest.
The shortest lag time. That's right. So it has the shortest lag time. Okay, guys. Thank you. I will record all the other lectures and I will give it to you at once, inshallah.